Dear students, we are continuing the classification of signals. You have studied about two different categories. First category is continuous and discrete time signals, and second category is periodic and aperiodic signal. Through this lecture, you are going to study about even and odd signal, that is a third category. So what do you mean by an even signal? Actually, even signal is otherwise known as symmetric signal. So even signal means any signal that is satisfying the condition x of t is equal to x of minus t can be what? A symmetric or an even signal. So here I am drawing a signal. So here if I am taking, this is your y-axis and this is your x-axis, and I am drawing a signal like this. See, the signal is like this. Okay, the signal is like this. This is the signal, given signal. So if you are considering, this is your origin, that is having the value 0. This is your t-axis, that is moving towards right and left, and this is your x of t, that is y of t. Y-axis is representing the quantity x. Now if you are taking the mirror image about the y-axis, that means mirror image about this point, the right hand side will be equal to the left hand side. Okay, that means if I am taking x of minus t, that means if I am substituting every t is equal to minus t, I am getting the same signal x of t itself. If that is the condition, that means if any signal is satisfying the condition x of minus t equal to x of t, then that signal is said to be an even signal. That means the signal will be symmetric about the y-axis. Okay, the signal will be symmetric about y-axis. Now, what do you mean by anti-symmetric signal or odd signal? That is just opposite of this particular signal. Here the condition is x of minus t equal to minus of xt. That means if I have a signal like this, here I have a signal like this. This is my signal on the right hand side of the y-axis, and this is my signal on the left hand side of the y-axis. So what is happening is, here if I am taking x of minus t means this is my positive axis, I need to take the negative axis. This will be actually minus into minus of x of t. That means this is equal to minus 1 into x of t. Okay, so how this minus 1 is coming here is that, here suppose that I am taking x of t here. X of t is this. What is x of minus t? X of minus t means I need to take the mirror image of this. That means x of minus t will be like this. Okay, x of minus t will be like this. Then from this x of minus t, how I can get the original signal? If I am multiplying this x of minus t with minus 1, I will be getting the original signal. That means what? X of minus t is equal to what? Minus of x of t. Or I can write x of t is equal to minus of x of minus t. Okay, so even signal means, or a symmetric signal means, it is satisfying the condition x of t equal to x of minus t, and odd signal means it is satisfying the condition x of minus t is equal to minus of x of t. The best example of an even signal is a cos signal, because if you are considering here, this particular signal is symmetric about the point y-axis. That means if I am taking mirror image about y-axis, then I will be getting what? This portion will be same as this portion. Okay, that is why the signal is known as an even signal. X of t is equal to x of minus t. Now what about this particular signal? That means it's a sinusoidal signal. If I am taking a sinusoidal signal, this part, that means the positive during positive time axis, the signal will be moving like this, and if I am taking the mirror image of this, it should move like this. Okay, this is the mirror image of the original signal, but the negative part is what? Not equal to the mirror image, that is equal to minus 1 into the mirror image of the signal. That means what? X of minus t is minus of xt. Best example is a sinusoidal signal. So here you have studied about the x of my even signal and odd signal. Okay, now how I can represent the even component and odd component of a signal. So even component means the component that are even in nature. Odd component means the component that are odd in nature. So according to this equation, that means according to equation number 1, any signal can be represented as a sum of its even and odd component. Okay, any signal can be represented as the sum of its even component and odd component. Here xc of t is known as the even component, and xo of t is known as the odd component. So if I can find the even and odd component of a signal, the original signal will be equal to the sum of the even component and odd component. Same way, if I am taking the mirror of this particular signal, that is x of minus t, then x of minus t will be what? I need to substitute every t in this equation as minus t. So x of minus t will be xc of minus t plus xo of minus t. Okay, if I am substituting t is equal to minus t. So what happening is, since this is an even component, that will obey what? It will obey the even property. That means this xc of t will be what? An even signal. So what is the condition of even signal? Any signal is said to be even, then that signal x of t will be equal to x of minus t. Okay, that means xc of minus t is even, means xc of minus t will be x of t. Okay, now you have xo of minus t. Xo of minus t means the odd component of x of t. That should obey the odd property, that is x of t is equal to minus of x of minus t, or x of minus t equal to minus of xt. That means x of minus t is equal to minus of xo of t. Okay, so xc of minus t is xc of t and xo of minus t is xo of t. So I can write x of minus t is equal to xc of t minus xo of t. Okay, so now I am getting equation number 1 and equation number 2. And from equation number 1 and 2, I can solve for the even component as x of t plus x of minus t by 2 and odd component as x of t minus of x of minus t by 2. Okay, so this x of t is representing the even component of the signal, and this xo of t is representing the odd component of the signal. Okay, so this is the case with even and odd component of a particular signal. Now we can see some examples. So here you have a question. Find the even and odd components of the following signal. Okay, so here you are given the question as x of t is equal to cos t plus sin t plus cos t into sin t. Okay, cos t plus sin t plus cos t into sin t. So how I can find the even and odd component? The even component can be found out by the formula xc of t is equal to x of t plus x of minus t by 2, and x of t is equal to x of t minus of x of minus t by 2. Okay, so for that you need to find x of minus t. How we can find x of minus t is that x of minus t is obtained by substituting every t in this x of t as minus t. So if x of minus t will be x of cos minus t plus sin minus t plus cos minus t into sin minus t. Now we know that cos minus theta is equal to cos theta, and sin minus theta is equal to minus of sin theta. Okay, so I can replace cos minus t as cos t and sin minus t as minus sin t. Here also cos minus t will be cos t itself. Sin minus t will be minus sin t. So here you will be getting a negative sign, sin minus sin t. Now I am getting x of minus t. X of t is there in the question. Add x of t with x of minus t and dividing by 2, I will be getting what? Xc of t as, if you are taking the sum of this equation, that means suppose this is equation number 1 and this is equation number 2. If I am taking the sum of these two, I will be getting 2 cos t. That divided by 2, I will get my even component as cos t. Okay, so same way, if I am taking the applying the equation xo of t, here also I need to take the sum of x of t and minus of x of minus t. Okay, so that means I need to take the difference between equation number 1 and equation number 2. If I am taking that, I will be getting 2 sin t plus 2 into cos t sin t by 2. that means x of t is obtained as sin t into 1 plus cos t. Okay, so this is how I can find the even and odd component of a particular signal that is represented as x of t. Okay, so take the next example. So here you have x of t is equal to what? X sin t. This one, x of t is equal to sin t plus 2 sin t plus 2 into sin square t cos t. Okay, so here also you need to find x of minus t, that is equal to that is obtained by substituting every t as equal to minus t in the given equation. So here I am going to substitute t as equal to minus t. So I am getting sin minus t plus 2 into sin minus t plus 2 into sin square minus t into cos minus t. Okay, again apply the same thing. Sin minus t is equal to minus of sin t. Sin here also sin minus t equal to minus sin t. Here you have 2 into sin square minus t. So sin minus t is equal to minus sin t. Okay, therefore sin minus t square is equal to minus of sin t into again minus of sin t, that is equal to sin square t itself. Okay, so 2 sin square minus t is equal to 2 sin square t itself. Cos minus t is cos t. Okay, so now I am getting x of t represented as equation number 1 and x of minus t represented as equation number 2. From these two equations, I can solve for the even component and the odd component. Okay, so this is how you need to find the even and odd component of a particular signal.